Welcome, mentors. In this series of videos, we'll explore bar modeling in mathematics and how we can use that in problem solving. So first, let's consider many ways we model in mathematics. We can do it through statements, we can do it through equations and inequalities, which is probably some ways that people recognize the most, but that's just one way. But we can also do lists, or we can also write sets, or tables, which is an organized way to deal with information. We can also deal with number line, pictures, diagrams in many forms, graphs, and also bar models. And in this video, we'll focus on this way to model math. Now, before we go into the math itself, let's understand what are the main two things that we want to achieve when we model in mathematics. So first, what we want to do is put up a system that connects the mathematical objects, and so that we can see the relations. And that's, I guess, the big advantage that models have. You just don't want to, talk about things without any relation. You want a model that holistically encompasses them. And then what we want to do, and this is more sophisticated, is relate different models that describe the same mathematical situations. And these models maybe one have more information than the other. They may not be equivalent, but you want to navigate through them because that builds understanding. And in this video, we'll only deal with bar models, but the point is that when you teach math, you could just not do bar models, but you could do other representations and connect it. That enhances understanding. Okay, so let's jump into the math. So bar modeling is a problem-solving technique. And so let's consider this problem. Carl has some money, and Monica has $200. Monica has $70 more than Carl. And the question is, how much money does Carl have? And of course, I can do this mentally, and maybe kids want to answer right away. But the point with bar modeling is that even if we start with simple problems, we can build their understanding. So let's do a bar model to solve this problem. So bar model. And so since we have two people involved in this problem, so Carl and Monica, that's the first thing we'll do. We'll put two bars to indicate these two quantities. So Carl and Monica. And so Carl has some money. Monica, we already know she has $200, so we may start with Monica. And so we just do a bar. For Monica, we can put an M here, and this is 200. Okay, so that's a quantity. And then we know that Monica has more dollars than Carl. So the bar for Carl should be smaller because it's less dollars. And so we do that. And so we just gotta, draw a bar that's less than Monica. And so the key is where to put the 70, right? So this is where this bar modeling helps in reading comprehension, for example, because I could put the 70 inside the C for Carl, but actually what I'm doing is comparing. So let's read it again. Monica has $70 more. So the key is the more. And so in bar modeling, what we do is we count this difference. So we put a little 70 here, and here's our model. So what we have is two quantities. One is 200, and the other we don't know, but it's 70 less because the other is 70 more. So now it's evident that we should subtract. So we subtract. And that's where the model is also important. We didn't tell the kids which operation to use. And it could be either add or subtract. Actually, the problem has the word more than, but we're actually going to subtract. We just see it right away from the model. So what we have to do is do 200 minus 70. So 130. And so that should be what Carl has. So now we can update this model, and we can draw it again. So we just refine our model. So we already knew this was 200, and then we know that Carl should have $130. And we can check that it makes sense. 130 plus 70, so we're adding. Okay, let me put this bar a little longer, which is okay. And so this makes sense. So the answer is $130. Okay, so that was problem A. And there you see this model, this comparison model. Before we get to the next problem, let's describe what the bar model is, now that you already saw an example. So in few words, it's visual algebra. Okay, it's algebra made visible with pictures. And so the bars represent quantities which may be known and also unknown. As in the problem we just saw, we drew a bar for unknown, which was Carl. We could still draw it. And so that's powerful. And then it's holistic, which means it treats things like a whole. You want to see the big picture there, the relation. You don't have just a list of isolated things like a detective dealing with clues. You just have the whole picture. And that's important because the brain likes holistic things. The brain likes to see things like the whole. And then it allows a scaffolding and different levels of complexity. We will not deal much in this video, but the way you should do it in teaching is start from simple bar models and then build all your way up to more complicated ones. So the uses are many: addition, subtraction, multiplication, division, ratios, decimals, and percentages. You can also use it in fraction operations like addition, subtraction, and even multiplication or division. And also geometric and spatial reasoning. It's perfect for that. Plus statistics, dealing with probability, different distributions, because the bars will just represent some data. Let's do another problem. And so this problem says the following. Carl has worked for 450 minutes, and Monica has worked 20 minutes less than Carl. How much time have they worked combined? Okay, so if I add these two times, how much would it be? Let's draw a bar now. So we know that Carl has worked for 450, so we can draw a bar that represents that. So 450, so he's worked a lot. And then Monica has worked 20 minutes less than Carl. And so now we know how to deal with this comparison, which, by the way, is comparisons in math, in problem solving, they're very hard for students in the beginning. So these models also help in that sense. So what we'll do is we'll put a bar for Monica that we know it's 20 shy of being Carl, because it says 20 minutes less than Carl. So this 20 here, again, is what's missing. So the question is not how much Monica, but in total. So this is what we would call a multi-step problem, because we have to do 2 steps to get to the final answer. So right away, we can see, and here I'll just update it right away, that Monica has to be 430. I can quickly check 430 plus 20 is 450. And so now I just need to add Monica and Carl. So just be careful, you don't add the 20, you just add the 450 and the 430. And so 400 plus 400 is 800, and then 50 plus 30 is 80. So I would get 880. And that would be combined. So this is the solution to this multi-step problem using bar modeling. Okay, and now let's look at a final problem in this video. Carl, Helen, and Monica are statue collectors. Monica has 50 statues more than the statues of Carl and Helen combined. Also, Helen has 20 statues more than Carl. If Carl has 80 statues, how many statues does Monica have? Okay, this is very complicated, right? Like you're like, okay, I'm out. But let's just do bar modeling and see how this can be attacked. And so what the advantage of bar modeling is that you're just like in a, I guess, meditation mode. You're just trying to understand what's going on, bringing things in, but you want to get to the big picture. You always want to tie this data, as I've said, and just have a clear view, like from the top. So let's do this. How should we start? Well, we have to have 3 bars, because we have Carl, Helen, and Monica. Okay, so Carl, Helen, Monica. So let's read. Monica has 50 status more than Carl and Helen combined. So what I should do is I should put Monica as a big bar, because she'll have a lot of status, more than the rest of the guys. So M for Monica. And I know that she's 50 more. So 50 more than Carl and Helen. Now, I don't know yet if Carl has same status as Helen or who has more, but for now I can just model them as if they had the same status, and we'll deal with that. So this is another important thing to understand. This SMART model may not, when you do the model, you may not exactly accurately deal with the, the lengths, but it's just a model. So the way you refine it, it's okay. So this should be Carl, and this should be Helen. Okay. So this is pretty nice. At least I know now a lot of information in pictures. And now I know the following. I know that Helen has 20 more than Carl, so I could make another bar model, and that's totally fine. So that was the first model, and then I know that Helen has 20 more than Carl. So I'll do the same type of picture, but now just dealing with Helen and Carl. So Helen has 20 more than Carl. And so the way you want to teach this bar modeling is it should be flexible. You don't want to make it mandatory to do this type of conventions. You want to give some freedom for the student. He has to get the model right in the sense of the meaning, but there's many different ways to write these conventions. Okay, so here should be Carl. Okay. And so now the natural question is, how am I going to relate these two models? So how can I relate these to produce extra information? And so I'll give you some seconds to think about it. And so probably what you guessed is that if we use the model in the bottom and we use that to replace Helen for C plus 20, and you see the algebra, but it's very visual, in the model on the top, then we're going to have a relation just between Monica and Carl. And that's one way. So what we're going to do is the following. We are doing the first model again, just with some modifications. So Monica is still Monica. She's still there. She's still 50 more than some quantity, but now the quantity, we're going to put C, but instead of H, instead of Helen, we're going to use the second model to change it to C and 20. So, and we can do that because it's the same length. So we're doing algebra without the variables, and that's helpful in the beginning. So now we know that Monica is 50 and 20, and Carl, whatever that means. So now we know also that Carl has 80 status. So this is where we use this absolute information. So Carl has 80 status, and so we put an 80 here and here. And so right away I can see how many status Monica has. So we can add, and again the students should know right away that it's an addition problem. They just see it there. So 80, 80, 20, and 50. And so 80 and 20 are 100, and 80 and 50 are 130. So the final answer should be 230. Okay, so Monica should be 230. Let's put these values now in blue to check if it makes sense. So 230. Carl, we knew it was 80. And Helen, we knew it was 20 more than Carl, so it was 100. So let's see if this adds. And it does, right? So I have 100, 180, and 50, and that's 230. Okay. So that's how we deal with this problem. And you don't expect your students to solve this right away. You can do some scaffolding. You can guide them through the process. But the model itself, it's what will validate whether they're going the right way or not. So it becomes a very natural judge, so to speak, in mathematics. So let's finalize by saying what are the advantages of using the bar model. And I've said some of them, but I haven't said some. So here's 6 different advantages. First, the most important, I guess, enhances conceptual understanding. It's all about the concepts, the relations, the procedures will be done, but after. It's just, this is not a game. Should I add? Should I subtract? The model will tell me that. Also helps reading in developing reading comprehension skills, and that's very important. I begin to associate actions to procedures and to relations, but in a meaningful way, so comprehension, not just tricks. I'm not trying just to guess that if the word more than appears in a problem, I should add, or if the word less than, I should subtract. We don't want to do that. We want to go beyond that. It also allows algebraic thinking, as you saw in these problems. It was almost like I was doing algebra with variables, but this is done without variables. And this prepares the way to using them. So we didn't cover this in this video, but it's easy to think about how these should become variables, right? You would just put letters to these bars. It also improves the ability to detect patterns, symmetries, because you have to move things around. You have to write these things in different order. So it's very playful, and that's good. It also can help students that struggle with English, and that's important. And finally, it helps solve problems, of course, but equally importantly, it helps me check for solutions, if they make sense, if they're reasonable. As we saw in this last problem, I put the numbers that I got back in my model, and I was like, yes, it makes sense. So in later videos, we'll explore some more problems using the bar modeling. Thank you.